Get started. So welcome everybody to the AK48G HDMI cable webinar. Lots going on today. We'll be talking fact or fiction with these cables. And on screen, you can see there a picture of two HDMI cables. These are right off the web. And you can see they're clearly marked 8K. One's 8K HDR, which is interesting, and you'll see why as we get into the presentation. But what's happening there is we're seeing these cables that are coming out 8K, HDR, 2.1, 48 gig, all kinds of claims, and there's no substantiation to the claim. And HDMI is going to require a certification that they comply with that standard. And the certification is going to be in form of a sticker that has to be on the packaging or has to be part of the marketing materials to show that it really will do 2.1. Of course, they haven't released the testing yet for it, and DPL is working on that also, on testing for 2.1. But until that becomes available, all this 8K is not really believable because there's no way to tell. So we'll move in. So I'll be presenting today, and Jeff Boccaccio from DPL Labs will also join in, and he'll be talking about the compliance part of it and the those specifications that pertain to that and what DPL is doing in terms of certification for cables. So Jeff's on right now, but he will be joining. So I have to admit some more people. Okay. Okay, so for today, what we want to do is we want to gain an understanding of the features of HDMI version 2.1. Now, there's some features in here that have to do with color depth, with frame rate, resolution, color sampling, subsampling, HDR. Now, these are all terms that I've covered prior in other webinars that talk about the basics of HDMI and what the meaning of all these terms are. For some of you that haven't participated in that and you would like to have a better understanding of those terms, shoot me an email whenever. I'll have that on screen. And if your company would like to have me do a webinar for them on the basics of HDMI or on the 2.1, I'd be happy to do that for you. So we'll also be talking about the performance requirements for version 2.1 compliance and the operation of link training. This is a new feature that's part of the 2.1 spec. That's a very interesting concept that they have HDMI has put into the performance specs of that, and I'll cover that pretty thoroughly here in a few minutes. Also, the testing requirements for version 2.1. And then how to identify true 2.1 HDMI cables. There's a lot of cables out there that you saw that we talked about at the start, that there are cables on the web that you can purchase that are advertising as 2.1, 48 gig, 8K, all kinds of things that there's no substantiation, there's no backup, there's nothing to show that they actually do meet the requirements because the requirements have not been released yet. So very nice, but people who buy them, of course, won't know whether they actually will do 2.1 or not for probably about 2 years until that content, 48 gig content, becomes available. It's not on the horizon yet. So I'm thinking it's going to be a couple of years before we see anything of that nature of 48 gig. So until that time, people can buy a cable that says that 2.1 do 48 gig, never know that it will or it won't until that time comes that content comes out. So what we want to do is provide you with the information so you can see around that, see through it, and know what's real and what's just marketing. So let's talk about the HDMI version 2.1 specifications that were released January of 2017. There's a lot of features in all on each of the HDMI specs. And one of the questions that comes up is, does a company, a manufacturer, somebody who makes the displays, receivers, disc players, preamp, pre-pros, cables, do they have to meet all the requirements in order to be labeled 2.1, or can they just do some of them? And if so, how many of some of them? Which ones, which not? These are the kinds of questions we don't have answers for yet. But what I strive to do at Tributaries, working with DPL Labs especially, is to make sure that we meet all the specifications of version 2.1, not some of them, and to their fullest degree. So on 2.1, the maximum uncompressed data rate is 48 gigabits per second. Now, 48 gigabits per second will allow 4K at 120 frames, 12-bit color, 444 color sampling. So that's 48 gig. Or go to 8K, you can go all the way to 60 frames, 12-bit color, but only at 420 color sampling. Now the maximum data rate can go higher with compression. So the system will allow up to 3.1 compression. And the question is, will all the different receivers and screens and sources allow that? Again, we don't know how that's going to be rated, but at 48 gig, it can be done. But at the higher compression ratios, you can get all the way up to 8K at 120 frames, 12-bit color 422, which actually works out to 128 gig, but compressed at 3:1. So the actual spec of 48 gig is for 4 channels at 12 gig each channel for a total of 48. Also will have high dynamic range, or dynamic HDR, a variable refresh rate, which really applies to the game mode, and then EARC for object-based audio, and this fixed rate link training, which I'll discuss on the next slides. Total specifications for version 2.1 were released in November of 2017. Let's give a second. Were released in 2017, and oops, got to go back. And the compliance test, the CTS, for the syncs, sources, and repeaters, those were all released in 2018. So you'll see some receivers that are out that they'll say that they have an EARC channel. They have a 2.1 capability. Screens that have 2.1 capability, because those testing specs had been released in 2018. But cable specifications, that the compliance testing requirements from HDMI are still not released. They're telling us now it's going to be late 2020 before those become available. So we're still waiting for that. High dynamic range. So high dynamic range in version 2.0 under the 4K resolution was static HDR, meaning it was one dynamic range that was average for the entire movie. But with version 2.1 under 8K, the dynamic range can vary frame by frame or scene by scene. So it's much more realistic in comparison to version 2.0, and also much closer to what the director wanted on his original movie. EARC is the Enhanced Audio Return Channel. This has been beefed up quite a bit. It's a bi-directional data channel using now the Ethernet pair instead of just a single line. We used to use the, I believe it was the hot plug detect line was used for that. Now it's the Ethernet pair. So we've got a shielded twisted pair, and that's going to allow a data rate of 37 megabits per second, up from 1 megabits per second in version 2.0 and 1.4. And this will be able to handle 24-bit audio, 192 kilohertz sampling rates, and Dolby Atmos, DTS:X, 5.1, 7.1, and 32 channels of uncompressed audio. So it's pretty beefy, much beefier than just ARC. And because it's common mode, it's a twisted pair, it's under common mode, it generates much lower noise than the previous model. So it's the right way to go. So here's device link training. Let's talk about this. This is an electronic method so having the devices agree on a connection speed. So the source and the display are going to negotiate and come up with the correct connection speed that will satisfy both units. This new protocol comes under the heading of FRL, forward rate link, tests transition speeds between devices. And the speed is based on the device's mutual support and the cable's performance capability. It's all dependent on the cable. The cable will make this particular function work properly or not. Fixed rate link channels, the FRL channels for audio and video. You can have 3 channels of video at 3 gig, which is the old version 1.4, or 3 channels of 6, which is our current version 2.0 for 18 gig, or in the new protocols of FRL, 4 channels of 6 for 24, 32, 40, or 48. So it's incremental. We could actually have video at 32 gig, video at 40 gig, or video at 48 gig. We could also have devices that perform only to 32 gig, only to 40, or only to 48. So that's something we have to see, is how the manufacturers are going to produce these devices. Are we going to have full 48 gig right off the bat, or it's going to be incremental, kind of like what happened with 4K in the beginning, where it wouldn't do 18 gig in the beginning until HDR became available. So that's something that would be left to be seen. This is all being managed by status and control data channel. Now this is new traffic. This is new data that's being put on the display data channel, DDC, that rides along with EDID, HDCP, and error protection. So we've got a lot going on with this particular thing. So anyway, excuse me for just a second. I just want to check there's a message on screen. Okay. So all this extra traffic is on that digital, the display data channel, and that's more work for the cable, the more performance requirement that the cable has to have in order to transport all this extra data. So the improvement in the performance of the cable over 2.0 is definitely something that has to be considered. So here's how it works. Devices are connected. So here you go. You got a display and you got a source, and you connect them up. Let's say it's 48. They're both 48 gig devices. You connect them up, and the EDID goes back from the display to the source. It says, "Hey, I'm 48 gig too." Source says, "Great." So the source then sends out a 48 gig signal to the display. If the display gets it intact, meaning if the cable is capable of transporting that 48 gig signal, the display gets it uncorrupted, and then it sends back to the source a go or a pass, meaning the link is good and training is completed, and now audio video transmission can begin at that accepted speed. If the cable is not capable of that, then the display doesn't respond to the source, or the source doesn't get a response from the display, then the test is repeated from the source at the next lowest speed. And this continues until the source gets a response back from the display that it has received the correct signal. And this can go all the way back down to 9 gigabits per second, back to version 1.4. The entire test should take no longer than 200 milliseconds. Now, what's not known is if the display manufacturers are going to provide on-screen display, so you could see what the final negotiation was. In other words, you turn it on. How will the user know what performance they're looking at? Are they looking at 32 gig performance? Are they looking at 40 gig? Are they looking at 18? Because this is all being done electronically within less than a quarter of a second. We don't know how that's going to work. We don't know if the manufacturers are going to do something about that or not. So how will they know? That's going to be one of the questions. But that's the link training. That's in process now. That's in the spec. So HDMI cable for 2.1. This now is called Category 3 cable, or ultra high speed Category 3. It's the fastest copper-based interface in residential applications and requires very stringent electrical performance standards. And this is some of the things Jeff's going to be talking about. Very important shielding construction requirements in order to meet the mandatory electromagnetic emission limits, now called CISPR 32. Used to be called FCC Part 15. It's now CISPR 32, which is actually more stringent than Part 15. So here we are, we're on the road to 48G. And we started on that road in 2002. In 2002 at 1080p. And then at 2009, it went to version 1.4. That gave us 4K at 24 frames per second. And then in 2013, we went to 4K at 60 frames. And in 2017, we got 8K at version 2.1. But along with this comes caution. Now, in order to help you understand a little bit more of this, we're going to turn it over to Jeff. And Jeff, I'm going to try to give you this screen and give you the remote control. And I have to find you on my list. Oh, there you are. Okay. Okay, it says waiting for DPL Labs to control your screen. So I think you have the con, Jeffrey.
Okay, very good. Well, good afternoon, everybody. Welcome to a Friday afternoon, getting ready to can the week out.
Hey, Jeff.
Yeah.
Hey, Jeff, before you start, there were 2 questions on the chat. Can I just take a minute and answer these?
Yeah, sure. Go ahead.
Okay. Jamie asked, how does that affect receivers? Talking about the link training, I think. How does that affect receivers that are in between? Well, the receivers have to be able to meet whatever the specification is. Everything is negotiated. So the receiver is going to be part of that negotiation. So if the display comes down and there's a receiver in the line, the receiver is going to have to be part of the negotiation. So everything in the path will have to meet whatever the speed requirement's going to be that the source sends. So it's got to be part of it too. So everything has to match. Aaron asked, does the training happen every time the system turns on? I would believe that's correct, Jeff. That sound right?
Yeah, it starts negotiating as soon as hot plug starts.
Okay, hot plug is the one that does it, right? Okay, that was it.
Okay, sounds good. Okay, let's see. Where was I here? So anyway, so welcome to the webinar, and Joe asked me to come in and maybe give you a little bit of insight as far as all of this about all these cables that are out there in the field.
Hey,
and
hey Jeff, can I stop you again for a second? I'm sorry. Just for everybody knows, I always, when we do webinars, I always think about these are our dealers and people who know Tributaries, they know DPL Labs, and I'm just realizing there are quite a number of people that are participating in this that are not Tributaries dealers and don't understand. We work very closely with DPL Labs. DPL Labs is a third-party laboratory that certifies HDMI cables, performance of HDMI cables. And actually in North America, it's the only place that you could go with a cable an HDMI cable and say, hey, I need a performance verification on this particular cable. DPL Labs could do that. They're the only ones, I say North America, could be most of the world, that can actually do this kind of testing and come up with a complete performance specification. Also, DPL works very closely, we work very closely with them on the design of our cables to make sure that our suppliers are designing the cables for the performance that we want to have. So, excuse me, there we go. So the performance limits are really important, and DPL Labs is a great partner in that to make sure that what our suppliers are making for us are what we want them to make. And Jeff does that through all his testing and of that. So, Jeffrey, I'm sorry, I meant to get that in there before. Please proceed.
So DPL Laboratories has been around for quite some time. We started about, just about 1.3, and we started primarily because the interoperability issues climbed dramatically. And our sister engineering firm, we made some electronics for it, HDMI, and we were seeing the same problems that everybody else was in the field. And we decided at that point we'd start looking into it. And eventually, we knew at that point that some of the problems that were being generated had to do with the way the product was operating and could have been tested in a different way that would circumvent all these problems in the field. Started DPL Laboratories, and of course, it grew over the years. We're really the only third-party testing laboratory for HDMI, even though we do quite a bit of digital video as per like the DisplayPort and such. But DPL is a big beast. I'm sorry, the HDMI is a big beast. They are the guys that really own the industry, and we have to, go out there and make sure you guys don't get plug and pray to death, and we don't want to go through that again. We've all experienced this. We learned over case studies how to solve those issues, and now we got to continue to do that because with every revision, there's always new. I'll use the term opportunities to find out, what happens in the field and in the electronics themselves. So that's where we came from. 48G is going to be a big one, and you guys got to be very aware of this. And it's a step up. You're going to have to really dig in to know what you are selling and what you're installing, because the framework of this is very elaborate, very complex. And of course, the more complex it gets, the more easy it is to go into an interoperability issue. So the whole idea is that not only do you have to up your game, but we have to up our game, because the equipment we used in the past, which we've already changed twice before that, now has to be all upgraded again. And when we went back to our typical test instrument companies that do this, we just weren't getting the personalized service that we expected, or that we expected someone of that caliber. When you're spending, $500,000 for an oscilloscope, you'd think that maybe, they'd give you a little bit of help, and they do to a certain extent, but they're also, servicing GM and NASA and the feds. They're multifaceted. They're not made just for HDMI. They're made to really measure everything. So in this go around, we decided to look a little deeper, see if we can get something a little bit better. And through time, it took us, a year or so to do that. We found a new partner that we were able to work with. They're much smaller. They're in Silicon Valley. They're much smaller, so of course they're much easier to work with. The people I work with there are actually the people that make the product. It's actually the people that actually write the software for it. And when I went to them and asked them if they could help us, they said, well, they think they could have just to, provide them with the specification I'm looking to do, and we can go from there. Well, it turned out they weren't good enough. They just didn't have what it took to get HDMI done. And the reason why was because they didn't operate at 50 gigs or 48. I'm going to use 50 just as a term. They operated at 400. So they're in a totally different league than what we're doing with HDMI. In fact, they almost laughed at me when I started showing them some of the things we wanted to do. and we had to kind of have them convince themselves that they'd have to get that thing to work down to 3 gigs. And that was a challenge for us. But they knew who we were. We have a huge international placement now. They found that out by way of research. They knew that we were a substantial firm in the industry, and they felt that maybe there's a good channel for them. And there is. And maybe I could touch on that real quick by the time we're over with this at the webinar. But with this new company now, not only do we get this incredibly large bandwidth, that of course, you know, when you get products that are so far above where you get a test, you get to see things that you've never seen before, and you get to test things you've never tested before. I mean, they brought test features in we never even saw before with the big boys. I mean, test features as crazy as, for instance, harmonic distortion. Now, when would you ever consider harmonic distortion part of HDMI? But, you know, you've got to think about how that whole thing works within the modulated envelope and how the higher data rates can affect that, either it's over copper or over fiber, it doesn't make any difference, or even over the electronic side. It's just a very, very wide, and it can be unstable if you don't watch it. So we got a lot of new testing features and ways of determining if products are wrong, or can we compare those tests with the tests we already have to make sure we can confirm those. And we did, and we were able to take all those, put them into a very, very elaborate automation process, because we needed speed. We needed a lot of speed, not in the data rate, in the labor, because the cost to do this is astronomical. I'm not even going to mention what those costs are, Joe. You can if you want, but they're now basically to the responsibility of the brand. So now each brand has got to go out and get their own products tested and pay the piper. And like I said, it gets very pricey. And what we try to do is we try to at least give them the best bang for the buck, provide even a better service, and also give them speed. And so these new guys made this thing so it's fully automated. And it's automated in a way where a test that would have taken us an hour to do, in this case, the 4 channels of video that we do, it would take us about a morning to get that done. Now this new test equipment can rip off four art patterns, four video channels, and it can rip it off in less than 7 seconds. So you literally click the button and boom, it's up. And not only that, it takes its pictures and it also transfers all the data out into the reports. So we gained a lot of speed with that. With the more speed we get, the less expensive it is, which means the brand, in this case Tributaries, doesn't have to then push that expense onto the price of your cables. So yeah, it's been a challenge for us, but now we're almost there. We just have a couple of little things left and we're ready to launch this. We should be going into full testing very soon. I know HDMI is talking about maybe the end of the year. We'll be before that. And we're going to have a little bit better testing regime to do that with. So what about all these cables that are out there, though? How are they doing this? And they do it because they can. You know, are there HDMI transmission lines ready? Are they really ready out there? Well, the answer to that is no, and they're not, because the compliance testing from HDMI hasn't even been completed yet. And until that gets completed, many companies don't have a prayer of getting those things out in the field unless they came to DPL Laboratories. And we would never even go there until we knew we were completely ready. And again, we're a little bit ahead of HDMI, but even still, both parties, HDMI and DPL Laboratories, want to make sure that those products work well. So we have to wait for permission. You just can't go out and start making these things and setting them all over the place. And so I'm going to try doing this, Joe. And it's not working, Joe.
Not working?
No, you want to change that for me? Yeah, thank you.
Okay.
All right, Joe's going to be the slide flipper for us here. So if they were ready for 8K, well, what direction would you go? This is where you have to step it up a notch, because the bandwidth is so big that, you know, and in fact, it's big just between the 24 to the 48. It's so huge. There's all kinds of features and benefits that are available within the interface, and they're all data rate centric. So you may find the 8K available at several places. I know of at least at 32 and at 48. And so what do you tell your customers? You know, do you tell them that they're going to have an 8K with a certain color depth and a certain amount of data rates? Or are you going to tell them that, no, you're going to go 48, you're going to get the best in the world? Well, you can, but you got to know you can. You can't just go out there and guess. And as Joe mentioned, you're probably not going to see that content come out the next year at least, and it won't show up until then, and that's when you get stung if the product doesn't meet those standards. So, how much of the envelope do you know? There's 48, there's 40, there's 32, there's 24, and then you've got to drop down into the old TMDS sections. And you've got to cover all of it because it's all going to be kept backwards compatible. So you can imagine how big this got. Go ahead, Joe, and flip it for me.
Okay.
So the bandwidth really got pretty big. So from an instance here, you're looking at this graph here shows you the lower end, which is 18 gigabits. Well, that's really not true. It's really 5 gigs all the way to 18, and we got up to a max of 4K. But you can see it occupies basically 50% of the total environment, and that's how we worked with then. It was easy. That was really easy. It's kind of like you guys going out there and wanting to get a really good power amplifier. It's only going to work between 20 and 20 kilohertz. You don't have to worry about it working to 100K. That's out of your realm. It's out of your wheelbox. But every time they increase that data rate, we get a bigger and bigger an envelope. And the larger the envelope gets, the more unpredictable the transmission line gets. And it's never going to be linear. It will never be a linear response. It'll always either roll off or have dips and valleys where it will work and sometimes where it won't work. And I'll show you that in a second. So next slide, Joe. So this is where you got to step up your game. You got to know what's going on because the cable selection is going to get really difficult now. Because if the cable doesn't have the wherewithal to be able to handle these data rates that Joe was just talking about, all the way up to 48, your features and benefits are going to be all over the map. And whether you have link training or not, you still have a concern because it seems as though the Chinese or the people that make televisions, they just love to throw those on-screen displays up there. I mean, they just love to throw the goodies. And, you got to know they're going to end up throwing those data rates up. And so, you go and make up a system and you deliver the system and the guy gets it home and, a week later, the guy calls you up and says, why is it only saying 32 and not 48? And it's because link training probably downsized it, either because the cable's performance wasn't good enough or the overall integrity of the data coming in wasn't good enough. And so now you got to consider, okay, well, that's really great. That means it's going to work all the time, so I don't have to worry about my plug and pray anymore. And that's true. However, on the other hand, you may have a liability issue where you've got customers that you sold them on 48G and an 8K, and now they can see right in front of their faces they don't have it. And so that's still not known yet when they're going to do that. I say when because it's inevitable. They always do. And so you got to keep an eye out for that. So on top of all this, next slide, Joe. On top of all this, then you got to look at this. And this, what I'm saying here is that this doesn't help. And I know you're looking at this saying, what is this? Maybe some of you know. But this is called an insertion loss curve. It's called an SED21. And this curve is part of what we call as S parameters. It's been out, this has been out since World War II. I mean, this has been used in analog for many, many, many years. And it basically shows you the frequency response of the product you're testing. So if it was a power amplifier, right, the span would be from, maybe 0 to 20 kilohertz. But not here. Here it's 0 to 12 gigahertz. So you can see it's a huge dynamic you got to deal with. And you can see with this particular test, it begins to roll off as we get higher and higher in data rates. But you can see the little dipsy-doos that take place. And that line you see there is what's called a limit line. And if it gets below that line, you're going to be in trouble. Something's going to happen. And this is what we call as the frequency domain. And the frequency domain is, it's been around for a long time, like I said, and that's really fine and dandy. But in today's day, with high-speed data, especially in high-speed video data, we work in the time domain. We don't really work in the frequency domain anymore. And so when you see curves like this that substantiate, oh, look, I can do 12 gigs, that doesn't necessarily mean that the transmission line is going to support that. And I'll show you why in just a second. But understand that if this blue line that you see there got really close to the pink. And then maybe so close that there was little dips and dews that breached it. There are certain parts of the transmission you're not going to get. And you're not going to get it in a bad way because it's going to affect it on the time domain side, not the frequency domain. So let's run the time domain real quick. And I go ahead and join into slide. I'm not going to, I didn't put this up here to confuse anybody. I know you guys don't use this type of tool as much as I do. I live with this. You know, I might as well wallpaper the office with this. You know, we live with this every day of the week. And we live with it because we're constantly analyzing it. And this is called an eye pattern. And this is the way you measure those things. And this eye pattern tells the story. I mean, there's SD21s in here, distortions in here, noises in here, everything is in here. And so by looking at an eye and understanding it with a trained eye to be able to look at this, you can detect not only how the cable's overall anatomy looks, you can also determine, you know, what's the likelihood of this thing ever going to go bad on someone over time. And they have limits in here that really help out. And I want to show you that because these are some of the things you're going to have to learn. Because as these cable products start coming up and as these fiber products start coming up, you better know whether these products are actually passing these things rather than just, you know, hopefully maybe working on the insertion loss I showed earlier. Next slide, Joe, please. So in this case, you can see here that up on the top, we have a thing called a unit interval, a UI. And that's basically the parameters between the data points. It just shows you the overall eye pattern. And in the middle, you see that little thing called an eye mask. And what that is basically is just a little, in this case, a little triangle. It could be other shapes depending on the interface you're using. And the whole idea is not to let any of the waveform, mostly in yellow there, we don't want any of the waveform to touch that mask. And the further away you away from them, the further you are away from the mask, the better you are. And so this is a kind of like a perfect one that I pulled for you. But there's all kinds of information in here. Next slide, Joe. And in this case, we have amplitude, which we looked at earlier on SD21. This shows us a little bit more on the insertion loss. One more, Joe, please. And then, of course, we got all these that can also be added to this eye. So all of these numbers, fall time, rise time, distortions, intercrest skews, all of these can be read off the eye. And when you get an eye, you can pretty much determine, even before you even go to some other tests, you know, where this product's going to be. And it's a fabulous tool. We use it all the time. And this is what's used, not only by us, but by every single ATC that HDMI uses around the world. Next slide, Joe, please. So in this case, what I did here is I wanted to give you an example of this. So again, I don't want to, you know, confuse you on this. I know you guys don't do this all the time, but just look at the pictures. You know, make believe it's a cartoon. Because you're going to see very quickly the obvious situations that occur. Now, this is our new oscilloscope. As you can see, it's got 4 channels up there, and it snaps all 4 of these in 7 seconds. And you can see in sample 1, this particular vendor sent in their samples of 12 gigs. This was a 2-meter long cable. And in sample 1, it looks very good. I mean, they're symmetrical, their noise levels are low, they're really robust. You know, it was a really good looking product, and I have to commend them on that. Except when we do these tests at DPL, we're a little bit different because, like I said, we've done case studies. We know what happens in the field. And what we want to know is, are we going to get this kind of results on all those cables? You know, we just don't know that. And so what we do is we ask them for random samples. So we have more than one sample to look at. We have a few. And so here's sample 3 of the same dialogue. Now notice what happened here in the lower right-hand corner. The eye pattern turned into this muckety muck. I call it muckety muck. And what it is it's an eye pattern. It's an out-of-phase eye pattern. There's discontinuities here that are severe discontinuities. Well, HDMI is intelligent. It doesn't know what that means. I mean, it's data. It's got to be read. Well, there's nothing to read there. So as far as HDMI is concerned, that channel's dead. So here we have these 3 samples, and one of them has got a failed channel 3. So immediately these guys, they failed. They're out of the box because you've got to maintain some form of control on this. But then just to show you just how crazy this bandwidth is, let's see the next slide, Joe. Now this is the same sample, except now we're operating at 6 gigs. We're not operating at 12 anymore. Now you notice, channel 1, 2, and 3 still look pretty good, but channel 4 has come back. It's got some wiggles there and it's got some noise and jitter, but it's a lot better than it was before, and it would easily work under 6 gigs. But no one would ever know this unless they actually went in and looked at this thing. And we do this continually, because even through DPL, we may pass a product, and we're tough. I mean, there's no doubt about it. We're hard on these guys. But when that thing gets out there, we know it's gonna perform. But we also know that 90% of the product comes from the Far East, and they tend to change things as things go on. So a vendor can order one batch of stuff, and the next batch doesn't necessarily have to be the same. And so what we do is once about every quarter, we go out and do a little secret shopper deal, and we go and get these cables and we look at them, and we want to make sure that they're still doing what we tested for these. And it's a major development, because it helps you guys in the field, with the likelihood of getting a bad product, or the likelihood of getting a product that has been changed. So this shows you the criticalness of what you're dealing with and what you're going to be dealing with. And when you're operating at 48G, again, you've got to operate throughout the whole band. HDMI makes this so that it's fully backwards compatible, and kudos to them. They did a great job with it. But these cables and fibers, they're not linear. As you get out in bandwidth, it's just like anything else you do. I mean, if you had a coax cable running cable TV, if you guys have ever done any of that, what do they do? The first thing they do, they go in there and see what the insertion loss is over a coax cable to RG6. The same thing. But, these guys are operating at, I don't know, whatever it is, maybe they're operating at a half a gig. But a half a gig is nothing to where we are. We're so far out there that the nonlinearities of that waveform can be really, really drastic. And it all depends on the twist ratios, how they made the product, what the dielectrics are like, and then of course from dial-out to dial-out. So you got to watch for that. And now with these mandatory tests in place, the likelihood of you having problems with these transmission lines like you had before really goes down dramatically. And there's other issues too. Go ahead, Joe. Let's move on to the next thing. And we also have emissions to worry about. We never had an emissions problem before. Under 1.10 all the way to 1.4, there was never an emissions test. And it wasn't worried about back then. And then as they went into 2.0, when they came over 2.0, they told everybody just to use 1.4 cable. So of course there's no emissions. I mean, it's still the same cable we made before. Now everybody questioned it, because we went from 9 gigs up to 18. We doubled it. You think maybe they're going to come out with another cable. They didn't, and so they let it go that way. And I think they got stung, because later on they came out with a premium rated testing, which was not mandatory. And in that non-mandatory testing service, they offered emissions, and these emissions can be really, really instrumental in the reliability of the systems that you put in, because they're, number one, they're intermittent. Number two, they're invisible. You can't see these. You'll never know where they are. And I'm sure you've already experienced this with lighting controls and even HDMI when things become intermittent, or even air conditioning systems. So these are emissions, and there's emission standards for this. And the government did this with Part 15. And now it's gotten even harder, where they've upped the ante a little bit, and they increased it to a better emissions designed specifically around multimedia. And so this is the next concern. Next slide, Joe. So, when you're looking at these emissions, they have to be mandatory. If everybody doesn't do it, you're going to be out there floating in the wind. I mean, you start installing these products and you don't know if it's past emissions. You could have cancer inside that system. You don't even know it. And you won't know it for a year or 2 or maybe 3, depending on where the customer's going. So this is why they made it mandatory, and it has to be mandatory, because things could happen. You know, they could cause problems with the Wi-Fi system in the house. They can cause problems with the internet. They can cause problems, which would, of course, would kill Netflix. They could have problems with computers and other wireless devices that are out there. It's very home based. But to show you how it is on a big scale, which probably you'll never see, Joe, once you snap that shot. What this is the spectrum that we're operating in. And you can see it's a wide spectrum. We're dealing with frequencies that are as low as 60 hertz, and we go all the way up into the gamma ray area. And these are all emissions. These are all being done. You guys have experienced this. I'm sure one time in your life you drove under power lines with an AM radio, and the speakers went nuts as the noise and buzzes came out. And those are emissions, but they weren't emissions that were going to kill anybody. They weren't emissions that was going to disturb anything, unless you literally drove over there. But you see, some emissions can be very dangerous in some cases. And this next case we're going to show you was very dangerous. Go ahead, Joe, do it. This is flight TWA 800 back in 1996. This is a jumbo 747. It was carrying 230 people on board, and it crashed over New York. Joe, you know exactly where that is, don't you?
Jamaica Bay, yep.
Jamaica Bay, yeah. And this was a major disaster. And of course, the first thing that came out was it was a bomb. Had to be a bomb. You know, it's got to be the terrorist. It's got to be a bomb. And you know, a while later, a day, two, I don't know what time it was a missile. Then it was a missile. You know, someone accidentally shot it down. You know, we live in the United States. You know, it's not going to happen. So, you know, you have to look at this, and as being aviators, right, Joe? As we're both aviators, yep. And we know exactly how the airspace works. Yeah, it's not going to happen. You know. However, what they found out later on, NTSB found out later on, was that the explosion actually occurred in the jumbo tank in the belly of the 47, and it was empty. And when it's empty, it's more prone to explode on the fumes. And a spark developed in the body, maybe from a loose rivet, maybe from a piece of metal. We don't know that. And it was probably caused by some outside emissions. And it turned out, after years of study, especially Harvard did a big study on this, that at that time, in that airspace, there were a tremendous amount of ordnance with Black Hawk helicopters and sonobuoys and radar planes and all kinds of emissions floating around. And it was a perfect storm for this thing to occur. Tragic, very tragic. But this is not going to happen to us in someone's house, but it could be that way on the telephone when they call up and tell you the system's down. Go ahead, Joe. So CISPR 32 is a change because it shields us from all this. It keeps everybody within limits. And this is, you have got to have this. The last thing you want to do is start installing things that you don't know if they're going to emit radiation. And I don't mean radiation like in, nuclear power radiation, but, radiated electromagnetic radiation, because it will affect everything. You know that you guys been through this before. You don't need it. Get rid of the problems. The old story, handle the problem before it occurs. And this is exactly how you do it. You put it through some really, really stringent measurements. And with that, you won't have to worry about problems later on in life. So, that's one major thing I wanted to at least share with you today. We could go on for probably 6 hours. I could tell you stories on what we're expecting under 48. But we're doing our best out there, guys. And we're trying to, circumvent anything that can happen out there. And things will, and we'll be on top of it. We always are. And we always get those phone calls from everybody. And don't ever worry about that. You're always willing to call us at any time. Next slide, Joe. And so to prevent this, the HDMI group, which is a good idea, is that they're now certifying these with certification labels. And you'll see there's DPL's label there. So when you see a DPL certified label on a product, all of these tests have been done, and more so, because we do more. Even in the emissions, we go further. We actually take the CISPR 32 and we dip down into areas that the HDMI spec doesn't even call for. And then, of course, HDMI's got their label, which is also good. They'll strap that on theirs. But when you see one of these labels on these products, you're good to go. You don't have to worry about that anymore. You go out and, worry about getting paid, or go out there and worry about, showing the customer how to operate the system. And that's what's so important really about today and where this is all going. And I think that hands it off to you, Joe.
Oh, great. Okay. Thank you, Jeff. All right. Well, thanks for bringing us up to date on all that. This certification is really an important consideration. And in the development of the cables, the ability to shield these cables properly so the emissions are kept down to a minimum or eliminated is one of the most important design characteristics for these new cables. One of the things that Tributaries has done since the beginning is in our shielding, not only are we using multiple layers of shielding, but we're shielding the connector head. One of the things that we did not too long ago was bought a number of cables that are on the market and took the heads apart at the connector heads and found that there was no shielding. So in that situation, this EMI testing they wouldn't pass it. And of course, the concern is how many cables that will be out there and marketed as 2.1 cables that haven't been tested for emissions and now aren't labeled and are being sold or could be sold for 2.1 that would have, being antennas, just broadcasting high frequency information out into the field, disrupting Wi-Fi, disrupting remote control systems and other things. So this is a really important part of it that I wanted to make sure that it was understood. So here's what we're looking at. Right now, there are quite a few cables that are on the market that are being marketed as 8K, 48 gig, HDMI 2.1. One of the claims that's out there is some cables that are saying, well, they're 24 right now, that they can do 24 gig. And the implication, of course, is that that's better than 18 gig. Well, not necessarily so. The HDMI cable that claims that 24 gig, they have 4 video channels that can do 6 gig each for a total of 24. That's true. I'm sure it is the case for them. All our cables, all the Tributaries cables can all do 24 gig. We have 4 channels that can each do 6 gig. We don't advertise it as 24 because 18 is the standard right now. But at 24, if you were able to use 24 and in an 8K environment, a 2.1 environment, then the best you'd be able to do is 8K at 24 frames at 8-bit color with 420. Okay, I mean, that sounds pretty good. The difficulty is you couldn't do HDR. HDR requires 10-bit color. You'd be better off using 4K at 24 or 60 frames, 10-bit color, 422 with HDR, which is 18 gig. So in this case, 18 gig actually will outperform the 24 gig because HDR would make all the difference. Having a 8K as compared to 4K really is of no consequence unless you're standing 3 feet from the screen. If you're like most people and you're sitting back 10, 15 feet from the screen, the resolution between 4K and 8K is pretty much indistinguishable. But the contrast, the HDR, the dynamic range, is definitely going to be there, as well as color. So that's something to look at, I think, very carefully. So let's look at some other cable brands. Well, here's brand A, and this is from their company website. What they say on their website is their 4K, 8K capability, and they talk about 8K 30 HDR, and again, right into that same situation. So 8K 30 with high dynamic range, which would mean 10-bit color, even at 420, is going to be 32 gig from the data rate tables. So they're saying that their cables have a 32 gig capability. Well, it's unsubstantiated. There's nothing to show that that actually is the case. What are they using to actually test that? What are their criteria? Nothing is mentioned about that. So there's no way to know what this really means except it's nice marketing. Then they go out to say that questions arise. First and foremost, are their cables compatible with 8K and the new features of 2.1? And of course, the answer is yes. Well, that's nice copy. But again, without any certification, without any backup, that's just nice marketing. Here's another one. This is right on the label, right on their packaging, 48 gig with Ethernet, 8K ready. No backup, no substantiation. Here's a beauty. This one is off the internet. They're showing 8K, 120 frames, HDR, 444. 8K 120 HDR 10-bit 444, that's 175 gigabits per second. I don't think so. I don't think that's going to happen. But again, there's no police out there. There's no HDMI police saying you can't say that. So companies are going to market as best they can to show that they've got better than someone else, even though it may not be the case. Another one, same thing, 8K, 2.1, 48 gig, right out there. Customers will see this and they'll buy these things off the internet thinking that that's what they're going to be getting. Another one, same thing, same type of thing, claiming 48 gig performance. So once the testing begins and either DPL or HDMI releases their testing that we can actually have certification, that's when you'll know that cables are capable of the 2.1 specification. So that's what we're looking at. This is the data rate table that, this is right from the HDMI forum website, by the way. And you can see the 8K 24, 420 10-bit color is 32 gig. That's the lowest one at 8K. They don't even show 8-bit color. None. This is all 10 or 12-bit color. And the data rate goes from 32 all the way up to 128 is the highest, 128 gig. But this is all very highly compressed. So you can see what that's about. So this is, here, getting this transitioning from 2.0, 2.1 for a company like ours and companies like yours is a very important thing to be considering. And I know as a company, we always in the past we've been testing all our HDMI cables. So we do 100% test on all our cables at 18 gig currently. So we do 100%. Every cable is taken out of its packaging, tested for 18 gig, and then repackaged and sent. So we catch bad cables before they go. Jeff does the certification on the initial runs and runs in between, but we're doing every day 100%. We will be testing these cables at 48 gig when they become available also to ensure that the cables that our customers are getting are truly 48 gig cables and will comply with all the 2.1. And I think we're the only company in the industry that is doing that currently and will continue to do that to support our dealers and make sure they're getting everything that they know that they should be getting. So we want to make sure you keep an eye out on those other brands that are advertising these things so that you know what it is they're advertising. And in that transition from 18 gig to 48 gig, Tributaries will stay on top and keep above all the others to ensure that what you're getting from us are the proper cables. We should have those cables before the end of the year. Fourth quarter is what we're looking at. We're just waiting now for the testing specifications to be finished. And if DPL has their testing specifications and their labels ready to go, that's what we're going to be doing. So we'll have those cables then. So as soon as they're ready, and as soon as that we can have that testing done and the labels prepared, we will begin selling 2.1 cables, and we'll keep you informed on all of that. Here we are at the end of the presentation. What questions do we have? We could do it via chat, or you can open up your mics, however you want to do it. Somebody just came back, asked for what the projected pricing is. That's a great question. Thank you, Anthony. Tony Bastanti. Hey, Tony. That's a great question. it's going to be higher than where we are now. And the reason is the EMI testing that's required on the cables has increased the cost dramatically. It's a separate cost. Also, the companies now have gone to, or HDMI has gone to on their testing, that they used to just test individual cable groups. So if we gave them a 3-meter cable and it passed all their tests, they would then say, okay, well, that includes everything below 3 meters. That's gone. Now they want testing and payment on each length of cable. Now, DPL Labs hasn't set up their schedule yet, so we're not sure how that's going to work. But because there's more testing required, the costs are going to go up. How much, I don't know, Tony, but as soon as we have them, we'll let you know. Let's see, Jim asks, what is the longest passive cable length for 48? Right now, it looks like 3 meters is about as far as we can get on a passive copper cable. And on the active cables, that's still a matter of experimentation yet to find out how that might work. Jeffrey, do you have any input on that one, on the active cables?
Yes, we've done some experiments with some cable manufacturers in China. We're very exposed in China. We're there quite, at least we used to be there quite often before all this virus stuff. And we got great relationships out there. And we know a lot of the cable manufacturers that are making those cables for you guys. And they're out there trying to find ways of making it go past 3 meters, say. And of course, that's all justified by either the gauge, you know, or the quality of the copper itself. But the we did get one in here that was rather interesting. We actually were able to test it. It was a 24 gauge, but it was 10 meters long with an active device in it. So it's doable. It's clearly not less expensive than fiber, and it would substantiate, you know, some relatively good lengths. And another one here, Joe, that someone asked about too, is about making some testing for the field for the guys to test for future products. And that's going to be a tough one. You're gonna start seeing some products start coming out with this. Our new testing company that we're dealing with, our new instrument company, is working with us. We're designing a system so that it could be a production system, so that these manufacturers that want to do it right, instead of having a TV at the end of the production line that they plug into, they will actually plug into a test instrument. And the instrument will be very similar to what we have in our waveforms, where the operator will actually be seeing the eye patterns as each product gets ended and passed through. So I think you're going to see a major increase with testing going on prior to them even leaving China. Depends on who the company is. You know, some companies don't give a damn and they're going to still use TVs. And then there are other companies that are very critical and they want to make sure it's right. And so that's always been something they always wanted to do. The problem is they could never afford it. And what we're trying to do is build a product that is nowhere near the capabilities of what we use, but at least maybe give them a chance to spot on eye patterns in production.
Okay, thanks, Jeff. John Villano asked about the Vega cable. No, the Vega cable is an 18 gig cable, and that's the limit of the chipsets, the optical chips that are in that system. But for those of you that have used the Aurora cable, our original cable, that's a 48 gig cable. Now, whether it'll pass all the functions of HDMI, that's another issue. But on the video side, we do know that it will pass 48 gig signals. So that's a great one. Now, in terms of what's coming for AOC, which are the active optical cables, which are the hybrid fiber cables and copper cables, right now we have access to a 10-meter active optical cable that will do 48, and we hope by in the fourth quarter that they will have a 15-meter that will allow us 48 gig, will pass 48 gigs. So That's in process. So I think by the end of the year, we should see a nice complement of these cables starting to develop. And again, since 48 gig content is a couple of years away, the development process, especially on the optical chips, because what I'm looking to see is a full optical cable that is just a cable, an optical cable, and then we could do the electronics on either side. And that's in development. So that's another piece that we'll be looking at doing. So that's it. Powered at both ends. Most probably not. You know, I think we found that the Vega cable, we can power it at one end, and it works fine. And it's just a matter of doing that design process with the 48 gig cables. But it all has to do with the chipsets, the silicon, that these chipsets have to become available that can process this data rates and change them into optical formats, and then retrieve them from optical back to electronic form. So that's where we're going.
Joe, there's one more thing there, and that is when you go to your single fiber format, you'll probably have to use double supplies on that because there'll be no copper in between.
Right. Yeah, it'd be a duplex system, right? You'd have to have system going back and forth, so it would be multiple cables within there. So, yeah, all this is in development, and we're staying ahead of it and on top of it. Any other questions before we close it down? Well, all right. Thanks for sharing your time with us today. I appreciate it. And you can email Jeff or me anytime, and we'd be happy to answer your questions. Call us if you need. We'll talk on the phone with you too. Just let us know what you need and we'll be there. So thanks again. Thanks for taking the time. Jeff, thank you for participating today. Thank you for DPL Labs.
You bet. See you guys.
Okay, take care.
Thank you, Jeff and Joe.
Yeah. Okay, thank you.
Take care.